Imagine a volcano that doesn't erupt with fiery molten rock, but with something cold and icy. Sounds impossible, right? Today, we're diving into one of the most astonishing discoveries in our solar system, worlds where lava isn't hot, but freezing cold. These aren't the volcanoes you learned about in school, they're alien wonders reshaping entire planets with ice instead of fire. Get ready to have your mind blown, because we're about to explore the baffling science behind volcanoes that spew frozen slush. When you think of a volcano, your mind probably goes straight to towering mountains of fire, spewing glowing red rivers of molten rock. That's how it works here on Earth, driven by intense heat deep within our planet. But out in the dark, frigid reaches of our solar system, there are volcanoes that operate on a completely different, almost magical, principle. Scientists call them cryovolcanoes, which basically means cold volcanoes. Instead of hot, gooey rock, these incredible geological features erupt with things like water, ammonia, or methane, all in a freezing cold, slushy state. These aren't just tiny vents, some are massive structures that have shaped the surfaces of distant moons and dwarf planets. Take, for instance, Saturn's moon Enceladus. It's a small, icy world, but it's constantly shooting out massive plumes of water vapor and ice particles from its south pole. These aren't steam from boiling water, they're eruptions of liquid water from a vast ocean hidden beneath miles of ice, venting directly into space and freezing solid almost instantly. This frozen lava then rains back down, covering the moon's surface in fresh ice. Or consider Triton, Neptune's largest moon. When Voyager 2 flew by in 1989, it spotted towering geysers of nitrogen gas and dark dust erupting thousands of feet into its thin atmosphere. This wasn't just gas, it was nitrogen that was liquid deep below the surface, heated by unknown processes, then bursting out and freezing into dark, icy streaks on the moon's surface. It's like a reverse lava flow, painting the moon with frozen plumes. But how does any of this happen? How do these distant, icy worlds, far from the sun's warmth, generate enough heat to melt ice and create liquid lava that can erupt? It seems like a huge puzzle. The secret lies in incredible forces at play, often invisible to us. For moons like Enceladus, the massive gravitational pull of their parent planet, Saturn, in this case, acts like a constant, cosmic massage. This tidal flexing stretches and squeezes the moon, creating friction deep inside. It's similar to how bending a paperclip back and forth repeatedly makes it warm. This internal friction generates enough heat to keep a massive ocean of liquid water existing under a thick ice shell. Pressure builds up in this subsurface ocean, eventually finding cracks and weak spots in the ice crust, and out comes the icy lava. On other worlds, like Pluto, the story might be a bit different. On Pluto, we see huge, dome-shaped mountains like Wright Mons and Picard Mons, which are thought to be giant cryovolcanoes. Instead of explosive plumes, these seem to have oozed thick, viscous slurries of water ice mixed with ammonia, flowing slowly like incredibly cold, thick lava. The ammonia acts like an antifreeze, keeping the water liquid at much colder temperatures. The internal heat source for Pluto is still a bit of a mystery, but it could be from residual heat left over from its formation, or even some radioactive elements deep within its core. Either way, the result is the same, liquid material making its way to the surface and freezing, building up these strange, icy landscapes. These frozen volcanoes aren't just geological curiosities, they completely change our understanding of where life might exist. The discovery of liquid water oceans beneath the icy shells of moons like Enceladus and Europa, kept warm by these internal processes, offers tantalizing possibilities. These hidden oceans, sometimes warmed by cryovolcanic activity, could be perfect environments for alien microbes to thrive, tucked away from the harsh radiation and extreme cold of space. It's a breathtaking thought, worlds where volcanic activity isn't destructive fire, but a source of life-sustaining warmth and chemical energy. So, the next time you think of a volcano, remember that our universe is far more diverse and astounding than we often imagine. Beyond the fiery peaks of Earth, there are ice volcanoes spewing cold, slushy lava, creating breathtaking new terrains and possibly even nurturing life in their hidden depths. It's a powerful reminder that the universe still holds countless secrets, waiting for us to uncover them. If you found this icy mystery mind-blowing, hit that subscribe button and check out our next video on the universe's weirdest planets.